Hey guys, Mr. Backerberg here. In this video, we're going to look at some more right triangle problems. So in this example, we're looking at using an angle of depression, and we're told that the angle of depression from the top of a lighthouse, which is 130 feet above the water, down to a buoy, which is in the water, is 6 degrees. And we want to find the distance from the base of the lighthouse to the buoy. So we're going to draw ourselves a picture. So we're dealing with an angle of depression, which means an angle that's going down. So I'm going to say that this point right here is the top of my lighthouse, and I'm going to say that this point down here is my buoy. So I'm going to connect these points with a line, and this is going to form a right triangle in here. And we know that the angle going down, the angle of depression, is 6 degrees. This is a 90-degree angle. The height of the lighthouse is 130 feet, so that's our vertical distance. And we're trying to find the distance from the base of the lighthouse over to the buoy. So we're trying to find the horizontal distance. So I'm going to call that x. Based on what we know, the 130 is opposite of the 6-degree angle, and the x would be the adjacent side. So opposite and adjacent means that we have to write out a tangent equation. So I would do the tangent of that 6-degree angle equals the opposite side 130 over the adjacent side x. Now I want to solve to get x alone, so I'm going to multiply that x over to the other side since it's on the bottom of the fraction. So we would get x times the tangent of 6 degrees equals 130. But then I want x to be alone, so now I need to divide this tangent over to the other side. So I divide the tangent of 6 over to the right-hand side. Now I'm going to type this into my calculator, but I need to make sure that my calculator is in degree mode since we're dealing with a 6-degree angle. So in my calculator, I double check to make sure that I'm in degree mode, and I am. So I do 130 divided by the tangent of a 6-degree angle, hit enter, and we can see that the buoy is about 1,237 feet away from the base of the lighthouse. Now in this example, we're going to be making an indirect measurement. So from the top of a 100-foot tall building, a man observes a car moving towards the building. Initially, the angle of depression from the top of the building to the car is 22 degrees, but after the car moves, then the angle of depression is now a 46-degree angle, and we want to figure out how far the car moved. So in my first picture that I'm going to draw out, this first point is our man at the top of the building, and this second point is our car. So if I connect those to form my right triangle, we were told that the angle of depression at that first point was 22 degrees. Now we know the height of the building is 100. So the first thing I want to find is the horizontal distance the car is away from the building at this first point. So based on the information that I've got, 100 is the opposite side, x is the adjacent side. So I would do the tangent of 22 degrees equals 100 over x. I'm going to multiply that x over to the left-hand side. But that doesn't quite get my x alone, so then I have to divide the tangent of 22 over to the right-hand side. So we would get x equals 100 divided by the tangent of 22. Now I'm going to type this into my calculator to find that horizontal distance. So I'm already in degree mode from earlier, so if I go 100 divided by the tangent of 22 and hit enter, we get just a little bit more than 247.5 feet. Now we're not done because we're told that our car moved. So I'm going to draw out a second picture to represent this second set of information. So we've still got our man at the top of the building. Our car has moved closer such that the angle of depression is now a 46-degree angle. So if I draw in my right triangle, now this angle of depression going down from the top is 46 degrees. Our building is still 100 feet tall, but this horizontal distance has changed. So now if I'm setting up my equation, I would go tangent of 46 equals 100 over x. I'm going to multiply that x over to the left-hand side, but then I'm going to have to divide this tangent over to the right-hand side to get x alone. So I would get 100 divided by the tangent of 46. So now I want to find this new horizontal distance, and then to figure out how far our car traveled, we're going to subtract the two. And if I do 100 divided by the tangent of 46 degrees, we get 96.6 feet approximately. To find the horizontal distance that our car traveled, we're going to subtract our two answers that we got. So I'm going to do 247.5 minus 96.6. If I hit enter, we can see that our car traveled about 151 feet. In this example, we're going to use some trigonometry in navigation. So we've got a U.S. Coast Guard patrol boat leaving port at a bearing of 53 degrees. Our boat is traveling at a speed of 35 knots, which means 35 nautical miles per hour, and it takes 2 hours for our boat to get from point A to point B. But then at point B, we shift our course to a 143-degree bearing, and then we travel for 3 hours until we hit point C. We want to figure out how far away our boat is from point A, and we also want to find its current bearings. So the first thing we want to do is draw ourselves a picture. So I'm going to say that this point right here is point A, and that's where our boat is starting. Now it says that we leave this port at a bearing of 53 degrees, and bearings are always measured from due north. So instead of going straight up, this boat left port at an angle of 53 degrees, and it traveled until it hit point B. Now it says that it took 2 hours, and we were traveling at a speed of 35 knots, which means 35 nautical miles per hour. So if we travel 35 knots for 2 hours, then the distance that our boat has gone is 70 nautical miles. Now at point B, we shift course, and we shift to a 143-degree bearing. And again, bearings are always measured from due north. So instead of heading upwards, our boat traveled at an angle of 143 degrees, and we traveled for 3 hours. Now, if we're going 35 knots for 3 hours, that means that our boat traveled a distance of 105 nautical miles until we hit point C. Now, there's two things we want to find. We want to find the distance that we are away from point A, and we also want to find our boat's current bearings. So here's the first thing that we need to look at in here. We've got a triangle drawn out, but it would be helpful if we knew a little bit more about this triangle. So I'm looking at these vertical lines that I have drawn in my picture. Because they're vertical lines, they're parallel to each other. And one thing that we learned about in geometry is that alternate interior angles are congruent to each other. So since this is a 53-degree angle, then this would also be a 53-degree angle. Now this straight line going up and down through point B, well, the measure of a straight angle is 180 degrees, and if we know this large obtuse angle over here is 143 degrees, then this smaller angle on the inside must be a 37-degree angle. Now if I put 53 and 37 together, that happens to form a 90-degree angle. So this is in fact a right triangle in here. And if I want to find the distance from point A to point C, well, using what we know about a right triangle, I could do the Pythagorean Theorem. So I could take 70 squared plus 105 squared equals that unknown distance squared. So 70 squared is 4,900. 105 squared is 11,025 equals x squared. If I add those together, I get 15,925 equals x squared, but then I need to square root both sides. So that distance from point A to point C ends up being about 126.2 nautical miles. So that's the first thing we wanted to find. The next thing that we wanted to find is our current bearings. So again, remember, bearings are always measured from due north. So instead of going straight up, our boat is going down at an angle, and we want to figure out what this angle is. Now again, we're going to use something from geometry to help us out. These two angles, this angle right here and this angle over here, are corresponding angles, so they have to be congruent to each other. So it would be helpful if we knew how big this angle up here was. Well, we already know that this top piece is 53 degrees, so it would be helpful if we could find the measure of this angle on the inside. So what I can do is from this theta angle on the inside of this right triangle, 105 is the opposite, 70 is the adjacent. So I could say that the tangent of this angle theta is 105 over 70. But if I want to find what angle theta is, then I have to do the inverse tangent. So I'm going to do the inverse tangent of 105 over 70. And in degree mode, if I type that into my calculator, I should get about 56.3 degrees. So this little angle on the inside of my triangle is 56.3. Now if I put those together to form this bigger angle, we should get 109.3 degrees. So our boat is currently 126.2 nautical miles away from point A, traveling at a bearing of 109.3 degrees. That's going to be it for this video. Thanks for watching.